Hi friends, let's continue our discussions. The commonly asked question in the interviews is to talk about advantages of using recursion while coding. So basically, when we have to do multiple actions of similar type again and again, then we have two ways of working on it. One is iterative method. One is using iteration and other one is recursion. So iteration usually is a machine friendly, and whereas this recursion is human friendly. So what do you understand by this? The time and space requirements are least here, whereas here the time and space requirements will be higher. But it is a simple to understand. This needs a higher experience to understand what is being done. Now, what it makes any sense? Of course not. It's not making any sense as we think of it. So the best thing I would like to convey this information is through an example. So what example shall I take? Yeah, definitely. Let me use an example of Tower of Hanoi. This Tower of Hanoi, as a story goes, there is a huge tower, and along with that, there are two more towers. On this tower, some 64 slabs of varying sizes. The biggest one is on the bottom, smallest one is on the top. 64 slabs are there, which are put on this tower. And the story goes that we need to transfer these slabs from, so let me call this as A, B, and C. So move the slabs from A to B. So we can use C, and the condition. So condition is the upper slab anywhere must be smaller than lower slab. So when you put the slabs, make sure that the upper slab is always smaller than the lower slab. That means we can't place a bigger slab over a smaller slab. And the story goes that when anybody can solve this problem, that's a day when the universe ends. Something like doomsday. So that's something about the story. Okay, leaving that story apart, let's get back to how this is useful to our computation. Okay, so we can start working with say 3 slabs. So on A there is slab 1, 2, 3, and there are 2 places free, B and C. Now what we can do, so these are the slabs placed one over other, so you cannot take slab 1 out. It has to be slab 3 only should come first out. So let me take slab 3 out, place in the position of B. Now slab 3 is no more here. Then what can we do? Now slab 2 can be shifted. So let me shift slab 2 to C. What next? Where should I place slab 1? Now I cannot put it on B or on C because 3 and 2 are there, which are already smaller than 1. So we can't move slab 1. Yes, we need to make sure that slab 1 goes into B. So make a free space in B by shifting slab 3 over to C. Sure. So in C, there are 2 slabs now, 2 and 3. 2 is below, 3 is above, 2 is bigger, 3 is smaller. So the constraint is not disturbed, so it is followed, so no issue. Then shift 1 to B. 1 comes to B. What next? Then shift 3 to A. Then shift, keep 2 over 1 in B, and finally 3 over 2 in B. So we are done. Can we recall what we have done? First step was what? 3. Yeah, 3 was shifted from A to B. Second step, 2 was shifted from A to C. Third step, what? Yeah, 3 shifted from B to C. Fourth step, 1 is shifted from A to B. Then fifth step, 2 is shifted from, no, not 2, it has to be 3, because in C 3 was above, so 3 should be shifted from C to A, and then 2 should be shifted from C to B, and finally 3 should be shifted from A to B. Done. So that's a way we can solve. So if I want to say this in simple language, then these are the 7 steps to be taken to solve the tower of one eye problem with 3 slabs. Now what do you think will happen if there are 4 slabs? 1, 2, 3, 4. If there are 4 slabs placed in location 1, yeah, definitely it's not this simple. It would be definitely more complicated than what it looks now. So as the size increases, the complexity increases. Therefore, while solving that, we would require more and more expertise to understand the problem, more and more expertise to solve the problem, and all that. Now the question comes is how does this be solved using recursion? So if you look carefully what we did, I can split this into three parts. I can split this into three parts, and in the first part what we did, we moved 3 from the tower A, then we moved 2 from tower A. So 3 and 2 were moved from A. That means the upper 2 were shifted first, and then the lowest one is shifted, then the upper one were placed back onto the lower one. So if there are 4, what can I do now is, let me try to solve the same thing. So can I assume that there are only 3 are there instead of 4? Can I assume that there are only 3 are there? So 2, 3 and 4. Forget about 1. Only 2, 3, 4 are there. So can I shift them to C? I can do that. So the first step, 4 move from A to C. Then 3 you move from A to B, and then 2 you move from B to C to B. So instead of A to B, now we are making A to C, A to B, because we wanted to shift this whole thing here. After doing this, what has happened is the 2 has come at the bottom, then we have 3 here, then we have 4 here. Done. What next? Shift this. So after doing all these activities, we have made. So what is still left? Then the fourth one. No, 4 has to be shifted. Then the fourth one is 2 is shifted from A to C, and then repeat this. The fifth step is fourth one is shifted from B to A, then third one is shifted from B to C, and finally seventh one is fourth one is shifted from A to C. In doing this, all 2, 3, 4 are shifted to C. Now this one part is over. This is equivalent to this part of previous action. That is, the top portions are removed. Now one is free to move, so move one. Then repeat the same process. Shift these things on top of this using this same logic we had used in the previous one. Makes any sense? Hope so. Now there are n slabs. So there are n here, nothing here, nothing here. So first step, move upper n minus 1 from A to C. Then second, the lowest one from A to B. Then move those n minus 1 which you have moved from C to B. So what happens? First step, the n minus 1 come here, then the last one comes here, then these n minus 1 are placed on top of that. Then now the question comes is, how do you move this n minus 1 here? Yeah, so to move this n minus 1, then you continue to move n minus 2. So out of n minus 1, move n minus 2 and then continue the process. So that is recursion. So start with n, then you try to move n minus 1, then try to n minus 2, then try to n minus 3. So that way we will come down to 3. And once you come down to 3, you know how to solve the problem. So this is the solution for solving with the 3 slabs. So use it. Use that algorithm we had. So once that is done, then you continue back. So that's how algorithm can be used recursively. So what? How do you think it is human friendly? Okay, when somebody asks me how to solve this problem, there are n here, zeros here, zeros here. Then I will say move n minus 1 here. Then we are left with 1. Then move this. Then that 1 you move, and this n minus 1 you move here. That's the simplest way I can answer. Now you said how to move this n minus 1. Okay, then upper n minus 2 you consider and try to move n minus 2 here, then the last one here, then the other here. Okay, that's as simple as that. Then you ask me how do you solve this n minus 2 problem? Then okay, consider the upper n minus 3, move them, then you are left with only 1, shift it. So what was the logic here? The basic logic was move upper 2 and then get back those upper 2. This is move lowest slab. So in general terms, if you look at it, so if you are working with 3 slabs, what you did is first upper 2 slabs you moved, then the lower slab you moved, then placed back the lower 2 slabs. So 3 means you have to move 2 to keep only 1. Then if there are n, then you have to talk of n minus 1. So the first part, move n minus 1 away, then move the last one, then get back the n minus 1 back to it. Now the question comes is how to solve this n minus 1 problem. Then consider this whole thing as your n minus 1 problem and then start doing move upper n minus 2, then the n minus 1 and upper n minus 2 get back. The question comes is how to solve n minus 2 problem. Yeah, that continues till you get down to level 3, because only for level 3 we have correct solution, then for all others, I can just use the same logic and I can keep telling in an abstract way. Just move the upper things and then move the lower thing and finally get back the upper thing. That's as simple as that. Now the question is how to move this. So this can be again divided into one lower slab and its upper. So then move upper, move lower, then fix back its cap, and that continues. So it is very simple to understand in abstract sense. So it's why called human friendly. So we can very easily understand the logic, we can very easily implement it. But yes, every time we are using a recursion means we are calling the same function, calling itself. That's a recursion. So calling means the current environment has to be stored onto the stack, because when you come back, we need to start from where we left. So we need stack for every call. So if there are n data, then there will be n minus 1 such calls. So n minus 1 stack arrangements are required. Second thing is calling the function, getting back the result, calling the function, getting back result is definitely an overhead as far as the time is concerned. So there is overhead in space, there is overhead in time, and hence it's a costly affair in terms of space and time. Yeah, to understand the logic, to verify whether it works correctly or not, we can go for recursion in simple cases. But if the case is too complicated, then time and space should not matter. We should implement through recursion only. But if you can implement through iteration, then it is recommended not to go for recursion, because it's going to be having a lot of overhead in both in time as well as space. It's going to be highly time consuming and highly space consuming. So we need to avoid as far as possible recursion. But in today's life, when the problem complexity is too large, then thinking everything at a zero level is impossible. Therefore, we have to work at abstract level, and hence recursion will become inevitable. So wisely, we have to decide whether we should go for iteration or recursion depending on the problem, available resources, how much time you have, how much space you have, and all. So it's not just we cannot just strictly say it should be this or that. So it all depends on the situation we are working with. So take appropriate decision so as to either go for iterative or recursive methods. So that's it for now. Thanks for watching. Many more sessions to come. Keep watching. Thank you.